All right, good day and welcome back to Everything Mathematics. And today we're going to wrap up this week by looking at simplifying algebraic fraction. And I admit this may not be one of the easiest things to do. In fact, I usually tell students, you see, if you naturally have problems with adding and subtracting fractions, simplifying an algebraic one may not be that easy. So today we're going to take it simple. We're going to start by adding and subtracting fractions. Maybe I should have done multiplication first because multiplying is a lot easier than adding and subtracting in terms of algebraic fraction. Yes, why not? Let's do multiplying first, and next week, God's willing, we're going to focus on the whole idea of adding and subtracting, because I see when it comes to adding and subtracting, the whole idea of the LCM and common denominators plays a big role. And if you don't understand that, or if you're not comfortable with that, that's where the problem usually lies, and it may not have anything to do with the algebra behind it. So let's do multiplication, and then next week we're going to focus on this. So multiplication simply entails what? We're multiplying, or rather we're simplifying an algebraic fraction in with multiplication. So if we have a fraction, let's say a over b, and we are multiplying that fraction by c over d, let's say. The concept of multiplication remains the same. It's just that we have to appreciate the fact that we're not dealing with numbers and we're dealing with unknowns. So what could be done, we do. What we cannot do, we can't, and we don't, and that's just that. So in a case like this, remember, when we're trying to simplify a fraction, or when we're multiplying fractions, the idea is that we try to see where we could break down. That's what we do. And we break down from top to bottom on the opposite side, top to bottom on the same side, top to bottom on the same side. This is how we generally go about breaking down a fraction. And of course, as we know, if a fraction cannot break down, then all we simply do is multiply across. So we multiply this by that, and we multiply this by that. And this is all we do when it comes to the algebra. So here we will simply end up with AC divided by BD. And that's it. That's the answer. We cannot do anything beyond this because there is nothing here that could have broken down. Of course, sometimes we have scenarios where we could. For instance, you might have a scenario like this. You might have something like, let's say, 8a squared, and that is over, let's say, what? 7b, and then we are multiplying that by, let's say, b squared, and that's divided by what? Let's say 2a. Good. Sometimes we have a scenario like this, and this might look more high-tech and complicated, but really and truly it's not. To simplify something like this, again, the concept remains the same. There are one or two ways in which we could do this. We could multiply just like that if we want, and then break down. Or if we understand the logic behind breaking down, we could break down just like this. And I will show you this way because, again, it's good to get adept to the various strategies. Remember, when we're breaking down, as I showed up here, top with bottom on the opposite side, top with bottom on the opposite side, or top with bottom of the same fraction, top and bottom of the same fraction. In this case, top and bottom of the same fraction have nothing that is divisible by each other, neither this side here. But if we look across, we notice that we have things in common. So this b could cancel itself once, and this could go into b squared b times, as stupid as that sounds. 2 could go into itself once, 2 could go into 8 4 times. A could go into itself once, and A could go into A squared 8 times. And once we do this, we're good to go. 1, 1, and that's as far as we could break down. So our final answer here is 4A times B. That will give us 4AB. And as a numerator, we have, well, 7 multiplied by across there. So that's just 7. And that's it. That's our answer. We cannot go beyond that. That's as simple as it goes. So let's see if we could work out a few simplifying problems. Let's see if we could do two simple ones. This is one of the things that comes with practice, of course. Simplify. And the more you practice it, you start to see things that maybe you would have never seen only up in certain stages. So here, let's see if we have p cubed divided by, let's say, 2p, and we want to multiply that by, let's say, what? P squared divided by, let's say, 7p. And on this side, or have b cubed divided by 3, and multiplying that by 21 divided by b squared. Look at two simple examples. And here now, of course, we could see where we could break down. So we could look top and bottom. This p could go into this p squared. Let's see. This p could also go into this p times. What else could break down? Nothing else could break down. So that leaves us with p cubed divided by 2. That's it. And if we look at the one below here, 3 could go into itself once, 3 could go into 21 7 times. B could go into itself 1, B could go into b cubed, b times. Oh yeah, this one worked out even easier. This one end up being 7b. So you do need to play up with this and manipulate it. But don't worry, I swear I'll come back to this even stronger when we do the laws of indices. This might even make better sense for some of us who would quicker understand the laws of indices and how this thing really break down with each other. But in the next video, we're going to look at how we add and subtract algebraic fractions, and hopefully that will solidify the whole concept of adding and subtracting unknowns. So until then, feel free to like, share, and subscribe if you haven't as yet. And until the next one, you take care.